So particles can change state between solids, liquids, and gases. And when particles gain or lose energy because of either heating or cooling, they overcome or submit these forces, and that causes them to change state. So in heating, heating a substance causes it either to melt or boil. And melting is the process of a solid melting to become a liquid. And boiling is when a liquid evaporates to become a gas. And with cooling you can either have substances that condense or freeze. And condense is when a substance goes from a gas to a liquid. And freezing is what happens in your freezer. It's when something goes from a liquid to a solid. So when particles in gas lose energy, the forces between the particles go stronger, and the forces become strong enough to bind the particles together. The gas condenses and it becomes a liquid. So what process happens when a liquid's temperature reaches its boiling point? So at the boiling point, the liquid is transferring state, changing state from a liquid to a gas, and that's what we call, and that's the process of evaporation, and that is when the boiling point, boiling happens. So the amount of energy required for substances to change state depends on whether the forces between their particles are strong or weak. So for strong forces, if you have stronger forces between particles, it means more energy is required to overcome these forces. Substances with stronger forces between the particles will have higher melting and boiling points. If you've got weak forces between particles, that means less energy is required to overcome them. So substances with weak forces between particles have low melting and boiling point. Just to recap that, the weaker the forces between particles, the smaller the amount of energy required to overcome these forces. So sulfur, as an example, has a boiling point of 445 degrees Celsius. What state will it be at 444 degrees Celsius? So it's below its boiling point. And remember, at boiling point, that's when a substance transfers from a liquid to a gas. So if it's below that boiling point, it will still be a liquid. And the processes that cause changing states are melting, freezing, boiling. Which one have I forgotten? Melting, freezing, boiling, and condensing. And the different changing states from a liquid to a solid is freezing. From a gas to a liquid is condensing. From a liquid to a gas is boiling. And from a solid to a liquid is melting. So we can use something called state symbols, and they are basically letters which tell us what state of matter a substance is in. So there are 4 different state symbols you need to know. So an example of one is for solids is a little s in brackets. So an example you could use that for, if you had magnesium and it was solid, you could put Mg, the symbol for magnesium, with a little subscript S in brackets just next to it. Another state symbol you can use is an L in brackets, and you probably can guess this, that just means liquid. So for example, water, H2O, you could put H2O and then an L in brackets afterwards to show it's a liquid. The third one you need to know is AQ in brackets, and that's not quite as obvious. That basically means it's an aqueous solution, and that just means that there's a substance dissolved in water. So it's quite often used a lot more than just the L in brackets, because quite often things are dissolved in water. So an example of that, if you had sodium hydroxide dissolved in water, you could put NaOH, and then in brackets, little subscript again, AQ to show it's dissolved in water. And lastly, gas, you could probably guess again what this is, but just in brackets is a G. So another example, carbon dioxide, CO2 with a little G next to it in brackets. So to recap that, what do we call those letters that tell us the state of matter of substances in a symbol? In a chemical equation. So remember, they are state symbols. And what state symbols are correct for some of these next substances? So water, H2O, is a liquid. NaOH it can be aqueous, can be dissolved in water. It could also be solid. Chlorine, it could be solid, but not at room temperature. Chlorine is a gas at room temperature, and sodium is a metal at room temperature. So some forces between particles. Strong forces, to recap this. Strong forces, that's when large amounts of energy are required to overcome those forces. That leads to a high melting and boiling point. And weak forces have a small amount of energy required to overcome the forces between the particles, and that leads to a low melting point. And in chemistry, there are 4 state symbols. See if you can remember them. They're solid, so an S in brackets for solid, an L in brackets for liquid, an AQ in brackets for aqueous, and a G in brackets for gas. The exact amount of energy needed for a substance to change state depends on the strength of the forces between particles.